Just imagine a measurement so profound, it doesn't just tell you how far away something is, but when it existed. What if the very language we use to describe the universe had to fundamentally change, not for convenience, but for our minds to even grasp its true scale? Without it, astronomy would drown in numbers too vast for comprehension. In every science, there comes a moment when language must expand to match discovery. Measurements evolve as understanding deepens. The cubit yielded to the meter, the month to the precise tick of an atomic clock. Yet no transformation of scale has been as dramatic, or as necessary, as the one demanded by the cosmos. The rise of the light year was not born of convenience, but of survival for thought itself. When astronomers first ventured to calculate the distances of stars, they still worked in familiar terrestrial units: miles, leagues, astronomical approximations borrowed from navigation. But by the mid-19th century, those measures had become grotesque distortions. To describe the span between two stars in kilometers was like describing the width of the Pacific Ocean in millimeters. Technically accurate, functionally meaningless. The universe mocked such arithmetic. But if kilometers and miles became meaningless in the face of cosmic scale, what universal constant, what unchanging force could possibly restore proportion to our understanding of the immense? What was the elegant solution that saved astronomy from a wilderness of zeros? Only a new unit, grounded in something timeless and universal, could restore proportion to the discussion of immensity. That something was light, the most constant traveler known, immune to change, the same in every direction. The light year was a conceptual bridge linking time with distance through the invariant speed of light. It tethered the unreachable scale of the heavens to a single absolute law of nature. Defined simply, a light year is the distance light travels in the vacuum of space over the course of one Earth year, 9.46 trillion kilometers, or about 5.88 trillion miles. A number so gigantic that even this simplification merely shapes the incomprehensible into the imaginable. The genius of this measure is its duality. It is at once a unit of space and a veil of time. To speak of something 10 light-years distant is to describe a separation across both dimensions. It lies almost 100 trillion kilometers away, and we see it as it existed 10 years in the past. Distance and history become inseparable. The telescope becomes not merely an instrument of observation, but a time machine extending human memory beyond the bounds of Earth. If you're finding this journey through the cosmos as illuminating as we are, consider hitting that subscribe button and joining us for more explorations into the fundamental laws of the universe. Before this union of time and space, scientists used another benchmark, the astronomical unit, based on the average distance from Earth to the Sun, approximately 150 million kilometers. Within the inner solar system, it serves perfectly. Planetary orbits can be expressed neatly: Venus 0.7 AU, Earth 1, Mars 1.5 AU, Jupiter 5.2. But the astronomical unit, though elegant for planets, collapses before stars. The nearest star, Proxima Centauri, is about 268,000 AU away. Beyond a few significant digits, such numbers lose significance. The light year rescued communication from this wilderness of zeros. It is worth walking step by step through the arithmetic that gives the light year its magnitude, for within those simple multiplications lies the vastness of creation. Begin with light's constant speed, 300,000 kilometers every second. Multiply by the 60 seconds in 1 minute, then by 60 again for 1 hour, 24 for the number of hours in a day, and finally 365 for the days in a year. The final product, 9.46 times 10 to the 12th kilometers, expresses how far one beam of light travels as it races unceasingly from one anniversary of Earth's orbit to the next. No metaphor can translate that truly. It must simply be acknowledged as distance beyond ordinary experience. To put this in perspective, imagine a beam of light departing the sun now. In 8 minutes and 20 seconds it reaches Earth. In another 5.5 hours it sweeps past Pluto's orbital path, crossing the entire planetary family. In 1 year, that same beam has traveled 9.46 trillion kilometers, about 63,000 times the distance from Earth to the Sun. And the journey has just begun, because the nearest stellar systems are measured in multiple light years. Already the language of kilometers has dissolved. Only light itself can still be counted. It was natural that the discovery of light's finite speed would lead to the invention of this measure. What astonished scientists in the centuries following Römer's revelation was not merely that light travels, but that it travels identically for all observers. This single rule simplified a universe of contradictions. The constancy of light allowed astronomical distances to be expressed through an unchanging yardstick, the same for every scientist on Earth, on Mars, or orbiting a distant star. To measure in light years is to measure in equal truth anywhere in the cosmos. In the late 19th century, the concept solidified. Astronomers began to publish stellar distances in terms of the amount of time light required to bridge them. The shift was more than semantic. It reorganized the mental architecture of astronomy. Under the old numeric overload, even the closest stars seemed infinitely remote. Under the new measure, they fell into an ordered network of light time. The sky became a chronological map. Alpha Centauri stood 4 years in the past, Vega 25, Polaris about 400. With one glance, humanity could read not merely where the stars were, but when their light began its voyage toward us. Such recalibration reshaped how we relate to the night sky. For the ancients, the stars were eternal fixtures, unchanging points of light. The light year introduced a haunting irony. The stars we see might no longer even exist. A cataclysm 100 light-years away would be invisible to us for a century after it occurred. One 1,000 light-years away remains hidden for 50 generations. The sky above is a gallery of ghosts still shining from ages long vanished. Each photon striking the human retina carries a fragment of cosmic memory. In this sense, the light year is less a measurement than a language for the universe's autobiography. Numbers alone struggle to express its magnitude, but analogies help. Consider a scale that compresses 1 light year into a single meter. On that scale, the sun itself would be smaller than a grain of sand, and the entire solar system would fit inside a protoplasmic speck invisible to the eye. The nearest star would lie 4 meters away, and the entire Milky Way galaxy would stretch 100,000 meters, 100 kilometers, across the landscape. Even on this dramatic reduction, the light year still conveys unimaginable breadth. Creating such mental translations is not indulgence, it is pedagogy. Without visualization, even scientists lose proportion. Whenever distance exceeds comprehension, the human mind converts abstraction into metaphor. But the light year, once understood, becomes comfortable to thought. It gives us the ability to compare. The Andromeda galaxy, 2.5 million light-years distant, is about 600 times farther than the edge of our own Milky Way. A quasar 12 billion light-years away represents light that left before the Earth existed. Suddenly, the chronology of the universe unfolds quantitatively, not just poetically. Still, one might ask, why tie distance to time at all? Because no other universal constant connects every observer across the cosmos. The second and the year are not arbitrary. They are rooted in orbital motion and the physics of the heavens themselves. A year may be local to Earth, but the principle remains. Measure by the distance light covers in one revolution of a planet about its star. Substitute any orbital period and the relationship holds. The light year, therefore, belongs to a class of units that translate easily into the universal language of physics. It illustrates that the cosmos does not share human parochialism. The invention of the Lightyear also solved a practical problem of communication among astronomers. Converting huge numbers of kilometers introduces rounding errors and confusion. To say a star lies 300 trillion kilometers away conveys awe but little precision. To state about 32 light years carries both magnitude and immediacy. Observers can visualize photon flight times, the delays in observation, the period since events occurred. It becomes a common coordinate system uniting observational astronomy, astrophysics, and cosmology. The psychological effect of this unit cannot be overstated. Expressing distances in light years transforms the night sky from an anonymous scatter of points into a structured temporal landscape. Look upward, and you do not see starlight from out there. You see epochs strung together by light time. The moon shines from 1.3 seconds ago, the sun from 8 minutes ago, Sirius from the year 2017, Polaris from the 17th century. Every glance upward traverses centuries, millennia, entire geological eras. The sky is history written in light. Moreover, the light year connects directly to the very act of perception. The sense data entering the human eye are always delayed by travel time, even over microscopic distances. At cosmic scales, that delay becomes monumental. The Milky Way's core is 26,000 light-years away. The light we see left when modern humans were only beginning to paint cave walls in Europe. The most remote galaxies detectable by the James Webb Space Telescope lie more than 13 billion light-years away, light that began its journey roughly 200 million years after the Big Bang. Observation and archaeology merge seamlessly through this measure. To scientists, the light year also embodies hope. It ensures that no message, however delayed, is lost forever. Every photon carries information about its source, its color, intensity, polarization, allowing us to reconstruct events long past. When we detect the faint afterglow of distant supernovae or the microwaves of the early universe, we are reading data preserved across billions of light-years of travel. The cosmos itself is an archive, and light is the courier. But the light year has a lyric side as well. It redefines humility. When children learn that the sun's nearest stellar neighbor is 4 light-years away, they encounter the first glimpse of the true scale of existence. An interstellar journey so vast that even light, the fastest thing there is, needs 4 years to complete it. The mind suddenly perceives the smallness of Earth not as diminishment, but as belonging. To be part of such a grand space is to participate in its wonder. The term light year was first popularized in the late 1800s, but only gained formal acceptance during the 20th, coinciding with Einstein's relativity and the advent of modern astrophysics. By then, its implications had deepened. The light year was no longer just a unit of convenience. It was an emblem of the union of space and time, the natural offspring of relativity's new geometry. To describe the universe in light years is to acknowledge that distance and duration are not independent quantities but aspects of the same cosmic fabric. In every calculation today, from measuring exoplanetary systems to plotting galaxies billions of years in the past, the light year remains the essential ruler. It anchors our maps of the sky, defines our idea of remoteness, and sets the practical limits on exploration. Even our dreams of interstellar travel are narrated in light-year terms. Science fiction speaks of vessels crossing them faster than light, but even those imaginings use the same unit, proof of how deeply it has entered the language of aspiration. Understanding the birth of the light year is therefore more than an academic exercise. It represents a change in consciousness, the moment when humanity ceased to measure the universe by human footsteps and began to measure it by nature's own speed. In this change lay both humility and transcendence. We did not enlarge ourselves, we enlarged our definition of what could be known. From the rhythm of the pendulum clock to the flicker of light across the void, Our measures tell the story of intellect reaching outward. The light year is that story's culmination, an idea that converts human curiosity into cosmic scale using nothing but the constancy of a universal law. It compresses inconceivable distances into units of understanding. It makes the unreachable calculable, if not traversable. And it teaches that knowledge itself travels outward, like light, finite, persistent, illuminating everything it touches. In the next episode, we will ascend that scale step by step, from a single light second to a light hour, a light day, and beyond, charting how those increments map our solar system and carry us to the threshold of the stars. It is a climb through numbers and through imagination, a journey that begins with the flicker of a second and ends among the galaxies. If you've been captivated by the birth of the light year, make sure to subscribe for more mind-bending science. And to continue your cosmic journey, click on the video appearing on your screen right now.